First problem just asks us to find the integral of x squared from x equals 1 to 6. So all you have to do there is take the antiderivative. We know the antiderivative of x squared is x cubed divided by 3, right? It's just the reverse of taking the derivative. And we're evaluating it from 1 to 6. So that's going to be 6 cubed divided by 3 minus 1 cubed divided by 3. And so that comes out to 2/15. Question B asks us the integral of 1 over 1 plus x squared dx. And I look at that and I say, oh, I'm trying to find the antiderivative of that. I'm asking myself, what is that the derivative of? And I recognize it right away, or at least with a little bit of thought, as the derivative of arctangent of x. This one's an indefinite integral because it doesn't have any bounds, and when it's an indefinite integral, we need to make sure we include a plus c on the answer. Now C and D get a little bit trickier, but just a little bit. C here, we look at this and we say, oh, well, I know, let's see, the derivative sign is cosine, so the antiderivative sign is negative cosine. And I say, oh, the answer's got to involve a negative cosine. It's got to be 3x. But then I think, okay, wait, I can check my answers. I can always check by taking the derivative of what I found, right? So take the derivative of minus 3 or minus cosine of 3x, and I get positive sine, oh, that's encouraging, of 3x. Oh, but the chain rule says I need to multiply by 3. And that's not what I want. So what I really want is I want a 1/3 to cancel with that 3. So if I'm going to multiply that by 1/3, I also need to multiply this by 1/3. And so the answer turns out to be minus 1/3 cosine 3x plus c. We can do a similar process here. We can look at this and say, oh, that's secant squared. That secant squared is the chain rule from taking the derivative of something with tangent on the inside, right? Because when we take the derivative of something with tangent on the inside, we get secant squared. So you can actually work this one out and think the chain rule backwards. I can tell you don't need to do this because we're going to figure out a better way to do this. That it's going to turn out to be 2/3 tangent x to the 3/2 evaluated from 0 to pi/4. But ugh, I don't really want to try to think the chain rule backwards every single time, especially since the chain rule backwards won't always be obvious. How it works won't always be obvious. So we need a better way than just trying to recognize the chain rule at play and trying to think it backwards. So while we can often carefully think through the chain rule inverse, we need a more structured way to approach these integrals to make sure nothing gets misplaced when it gets just a little bit more complicated, right? I'm okay with you thinking through the chain rule backwards when it's relatively simple, like e to the 4x dx. That you can look and say, oh, if I was taking the derivative of e to the 4x, it would be e to the 4x times 4. So when I take the antiderivative, it's going to be 1/4 e to the 4x plus c. And you can check by differentiating that we got that answer right. And sure enough, we did. But you can see it gets a little more complicated very quickly, right? When you start thinking about that, okay, I can't do that for this problem here because, okay, I can't say, oh, the integral of e to the x squared is going to be e to the x squared divided by the derivative of x squared. It doesn't work that way because this is not true, because if you try to check your answer, when I didn't just do the chain, to take the derivative of this right side, you don't just need the chain rule, you also need the quotient rule. And so this just doesn't work. It's not good enough to just try to simply think the chain rule backwards, except for in the simplest of cases. And so we need a better way. We need a better approach. And so to figure out that approach, let's review the chain rule, right? We know the derivative of f of g of x is f prime of g of x times g prime of x. Right, so that tells us the antiderivative, the integral of f prime of g of x times g prime of x is f of g of x plus c. But this left side might be a fairly complex integral, and it's nothing's going to be labeled. It's not going to tell you which part of it happens to be g prime of x. It's not going to necessarily have to sit at the end. And so the good news is we're going to have a nice approach to this. We're going to use some substitutions to clean things up. We're going to replace g of x with u, and we're going to replace g prime of x dx. And we're going to look at its differential and replace the differential g prime of x with du. And so when I look at this integral, everywhere I see something that's highlighted, I'm going to replace it. So f prime of g of x is going to become f prime of u. G prime of x times dx is going to become du. And then I look at that integral and say, oh, that's just asking what has f prime of u as its derivative when u is the variable. And that would just be f of u plus c. And then we look at this and say, oh, wait, let's look at all the highlighted pieces. U du, and then u again. And so now we can substitute back that u is g of x plus c, and we get the answer that we already knew up here. But this is an organized way to make a cleaner integral that will be easier to see. Let's see this in practice. There's a bunch of steps for this, some recommendations, some hints along the way over here on the right. But let's look at this problem. Now I know that some of you may be able to do this first integral by just thinking the chain rule backwards, and that's fine, but we're going to go through the process to make sure we understand the process. So the first thing we need to do is we need to choose u. Usually we're going to choose u to be the nested part. Sometimes that nested part means denominator. But sometimes there are other ways we're going to choose the u, and we'll talk about those shortly. Here, I'm looking for the nested part, and so I'm going to I find the nested part to be the 5x, and so I'm going to choose u equals 5x. Next thing we do is we find the differential. Du is 5 dx. We can also think if you don't want to skip the step, you can skip all the steps of finding the differential, or you can write it as du dx equals 5, right? I'm taking the derivative with both respective x on both sides and then multiplying the dx to the right side, pretending that the derivative is a fraction, but it works out. Next thing we do is if we need, this is step 3, rearrange the integral u sub to make the substitution easier. Well, you only need to do that if everything's not clean and ready to replace. And so here I look at that 5x, it's highlighted in green up top, and say, okay, well, that's easy to replace. I'm just going to replace that with u. But then I go and say, oh, I also need to replace all the x's, the dx and the bounds. There are no bounds here, but there are dx's. And I look at that and say, oh, dx. No, I have a dx down below, but it's not solved for dx. I want it solved for dx to make the substitution as easy as possible. So I solve for dx and I say dx is 1/5 du. And now I can say, oh, I'm ready to replace everything. Right? Everywhere there's an x, I know what it's going to get replaced with. The 5x is going to get replaced with u. The dx is going to get replaced with 1/5 du. The 1/5 doesn't have any variables in it, so we can bring it out front. So now we've done step 4, we replace the dx, all remaining x's and bounds. So now we're in step 5, find the antiderivative of the simpler expression. And this is just the integral of secant squared u du. And we say, oh, we know what secant squared is the derivative of. It's the derivative of tangent. So we did step 5, now it's step 6. And so if it's indefinite, we sub back. If it's definite, well, this one's not definite, so we don't have to worry about that yet. Don't forget about the plus c. And so sub back and u equals 5x. Remember, you can always check by taking the derivative. Derivative of 1/5 tangent 5x is going to be 1/5 derivative tangent is secant squared of 5x. Then the chain rule pops its ugly head and says multiply by the derivative of the inside, which is the root of 5x, which is 5. Sure enough, that 5 and this 1/5 cancel, and we're left with secant squared, which is exactly what we started with. And so that tells us that we got the answer right. I'll leave it for you to use u equals 4 plus cosine 5x to show that the answer to this one is minus 1/5 e to the 4 plus cosine 5x plus c. Now, one of the big steps that we talked about here was rearranging the integral or the u sub to make the substitution easier. And you can see we did that. We rearranged the differential, so part of the substitution, to make things easier, but that shows up in other ways as well. And so let's see that in play here. Okay. This first problem, I'm looking for my u substitution. I'm going to choose u to be I'm going to try to choose u to be the nested part. U equals 4 minus x. And so that means du equals minus dx. And I say, oh, well, I want dx. I want to solve for dx, not for du. And so dx equals negative du. And at this point, I say, okay, am I ready to sub? That 4 minus x is going to replace the 4 minus x. The dx is going to replace the dx. And then I say, oh, I'm not ready to replace yet, because what do I do with this x? Sometimes the answer is rearrange the integrand. The integrand is the expression in the integral. And sometimes you want to rearrange the substitution. And I look at this and I say, oh, well, what is x in my substitution? And so I take this 4 minus x equals u, and I solve for x, and I find, oh, x equals 4 minus u. So I just rearrange the substitution, and now I'm ready to replace everything. And so replacing everything, I get the integral of 4 minus u square root u negative 1 times du. And at first you might look at that and say, well, why is that any better? Well, the answer is I don't have a nested part anymore. I do have a product, and I don't know an inverse product rule yet, and we won't learn it this semester. But I do look at this and say, oh, I think I can simplify this. I can distribute this across, and I could say, okay, minus 1 times square root u times 4 is minus 4u to the 1/2. Minus 1 times minus u times square root u is plus u to the 3/2. Now I can just use the power rule. One higher power than 1/2 is 3/2. Dividing by 3/2 is the same as multiplying by 2/3. One higher power than 3/2 is u to the 5/2. Dividing by 5/2 is the same as multiplying by 2/5 plus c. Are we done? No, we have one last thing we need to do. Our problem started in x's, it should end in x's. And so minus 4 times 2 is minus 8/3. And u is 4 minus x to the 3/2 plus